Prove by contradiction the following proposition. If a and b are positive real numbers, then a plus b is greater than or equal to 2 times the square root of ab. The first line of the proof is given below. Assume that positive real numbers ab exist, such that a plus b is less than 2 root ab. Okay, so let's start it off here then. It's already started for us, isn't it, here? Squaring both sides. Let's square both sides since they're both positive and one is smaller than the other. If we square both sides then the inequality will be preserved, won't it? Because one is smaller than the other. So the square of this must be smaller than the square of the other side. So this now tells us that a plus b squared, this object squared, will be less than this squared, which will be 4, and the square of this will be ab, won't it, to undo the square root. So now that tells us then that a squared plus 2ab plus b squared is less than 4ab, and this now implies that a squared, move this to minus 4ab, 2ab take 4ab is minus 2ab, isn't it, plus b squared is less than 0. We've just moved this over there, and so this implies now then that a minus b squared is less than 0. Okay. A minus b squared rather is less than 0, but a square number a minus b squared has to be greater than or equal to 0, since a minus b is a square number. Is a square of a number. So it has to be positive or 0. And this implies it's negative. This is a contradiction. So our initial assumption must be false, if everything else is okay. So our initial assumption namely that we started off here, a plus b is less than square root of 2 lots of square root ab. So our initial assumption, namely that a plus b is less than 2 root ab, must be false. Consequently, if it's not true or false, then a plus b must be greater than or equal to 2 the square root of ab, and the result holds, or the result is proved. There we go.